13, solve for n. We have two fractions equal. Remember, when two fractions are equal, the butterfly method, okay? So those multiplied 2 times the 2n plus 2 will equal 10 times the negative 2n plus 10. So let's do 2 times this part here. So 2 times 2n plus 2 will equal the 10 times the negative 2n plus 10. Now we need to distribute. So 2 times 2n is 4n. 2 times this 2 is 4. 10 times negative 2n is negative 20n. And 10 times 10 is a good old 100. Now, let's move the smaller variable. I'm going to move the negative 20n over to be with that positive 4n. How am I going to move a negative 20n? I'm going to add 20n to both sides of the problem. That gives me 24n plus the number 4 equals 100. Now move my number over to be with the other number. I get 24n equals 96. Now simply divide by what's in front of the n, 24. That comes out to be a perfect 4. So that n value right here is actually a 4. 2 times 4 plus 2 divided by 10, and negative 2 times 4 plus 10 divided by 2. Those will make the two fractions equal to one another. 14, solve for n. We have a fraction times our variable equals 9. So how do we get rid of multiplying by a fraction? Well, the easiest way is to multiply by its reciprocal. But if I multiply that side by 4 over 3, I have to multiply this side by 4 over 3. These 4s would cancel, 3s would cancel. You're left with just n, which is what you wanted. Here we have 9 over 1. I'm just going to go ahead and multiply across the top, 36, because 9 times 4 is 36, and 1 times 3 is 3. Now, simply, what's 36 divided by 3? It is 12. And let's go ahead and hit 15. Solve for n. Solving this, 4n minus 2n, I just combine like terms. That's 2n plus 1 equals n plus n, 2n minus 20. I recognize, well, let's go ahead and move the variable. Well, when we do that, we notice that the variables on both sides are the same, and we end up with this statement of 1 equals negative 20. That is false. That never happens. That means there's no solution. There's no n that could ever make this true. It's never possible to make that true. So therefore, here, no solution exists. If you would end up with a statement like 1 equals 1, which is always true, then it would be an infinite number of solutions. When you have the same variable on the side and you subtract them from both and they disappear, that's when it is this special situation where either nobody works if you have a false statement or everybody works if you have a true statement.